Okay, so looking at the specific problems from that worksheet, your first problem is to find the value of sine 30. So what you're going to do is you're going to go to your axes, and you know that your 30 value on your unit circle is the first line here. So that's going to be sine 30 for that angle over 30 degrees there. Our right angle is here. And we have, as we marked up here, our opposite and our hypotenuse. So we know that sine of 30 degrees again is our angle measure. Our theta is going to be our opposite value over our hypotenuse. So that's our blue over our red. So in the problem that you showed on your worksheet, you had labeled your opposite side as 1, your hypotenuse side as 2, and your adjacent side as the square root 3. Now the square root 3 doesn't really apply here because it's the adjacent side and we're not using that in our fraction, but if you were to calculate a cosine or a tangent value, that would be of use. But here, like I said, we're just focusing on our opposite side value and our hypotenuse value. So you'll notice when you go to transfer here, so you move it sine 30 equals, you're going to go to your opposite side value, which is 1, over your hypotenuse side value here, which is 2, and that's your answer. Sine 30 is 1/2. Okay, so looking at our next one problem here, 135, sine of 135 degrees. When you look at your circle here, this is kind of a tricky one because when you think of 135, that's not really a value that stands out immediately as being on the unit circle. So what you're gonna do with that is kind of break it down as far as where it would land on the unit circle. So you know that this line here could be 0 degrees or 360 degrees. This up here is 90 degrees. This one here is 180, and down here you have 270. So you're looking for the value again of 135. So you know it's going to fall somewhere here in this quadrant right here. So you can draw our line in. When you're finding out exactly what it will be, you can kind of count up. So 135 minus 90 is 45. So you know that this angle here is going to be 45. And that's because 45 plus 45 equals 90. So theoretically, if you know that this angle, counting backwards, so this would be like 0 to 90, and then 90 plus 45 gives you 135 because you always measure from this line here. So you know that this angle is 135. Then to get up to 180, that angle is going to be 45. So looking at that, this value here will be 1, as you had on your sheet. Your hypotenuse will be root 2. And this value here, your adjacent, will also be 1. So as we have them labeled, our opposite is 1, our adjacent is 1, and our hypotenuse is square root 2. So when you're looking at this, the way that it's situated, it's reverse of what we have up here, but the values are still all present. Our opposite, our adjacent, and our hypotenuse are all still present because it's all with respect to where our theta is. So when you're looking at your triangle and you locate your theta, which is your 45, you're saying, so what line here is opposite of what my theta is? And that's going to be 1, your value right here. When you're looking at what's your hypotenuse, that's always going to be whatever side is opposite the triangle of your, where your right angle is. So that here is going to be square root 2. So if we set up our proportion here again, you have your sine 135 is your opposite of your hypotenuse, which is your blue over your red again. So sine of 135 degrees here is going to be your opposite, the side opposite of where your theta is, your 45 degrees, which is 1. And then your hypotenuse is the side opposite of your right angle here, so that would be looking up here, so that's square root 2. So I noticed also on your paper that you had gone through the process of what's called rationalizing the denominator. So when you have a square root in your denominator, like you do with the solution to this problem, that's not ideal. It's okay to have them in the numerator, but you try to avoid having them in the denominator here. So what you're going to do is multiply by the square root of 2. You multiply by the value of your denominator as both the numerator and the denominator, because when the numerator and the denominator are the same, that fraction is really equal to 1. So you're just multiplying your value here by 1, but what you're doing when you do that is when you multiply square root 2 by square root 2, you get 2, and when you get 1 times the square root of 2, you get square root 2 on top. So you're really multiplying your original answer by 1, but the way that, it's kind of tricky, the way that you write that 1 as being a fraction with an equal numerator and denominator of square root 2, because that's the square root that's in your denominator in your original answer. See how when you multiply, so the goal of rationalizing is to get rid of the square root in the denominator. And when you multiply that square root 2 by another square root 2, it's like multiplying square root 2 squared, which gets rid of the square root and the square cancel out and give you 2. So that's how you get your 2 in denominator, and then 1 times square root 2 is just square root 2. Multiply anything by 1, it's itself. So that gives you your final answer here, square root 2 over 2, which has no square root in the denominator, and it's equivalent to your original fraction here. Okay, so moving on to the last problem here, you have sine of 240. So similar thing as with the last problem. When we draw our unit circle here, you notice again 240 is not one of the angles that you immediately think of when you think of a unit circle. So we're going to do the same thing as we did up here. We're going to count up to 240. So you know when you're counting up, this is 90, this is 180, this is 270, and this is 360. So we're going to 240. So you start here at 0, you go to 190, start here at 0, you go to 90, and then you go to 180. You still know it's more than 180, but you know it's less than 270. So you know it's going to be somewhere, your triangle is going to be somewhere in this quadrant. So 240 is 30 less than 270. Another way to think of that is 60 more than 180. So when you draw your triangle in, it's going to be in this quadrant. And your theta value, because when you're counting around, you want the angle between this line here and your starting point, you want that to be the 240. So this full angle is 240. But when you're going from the 180 degree line to where the hypotenuse, I guess, of our triangle is, that angle is going to be 60. Because the 180 degrees up here plus the 60 degree value of our triangle is going to bring us to 240. So we have our 60-degree triangle here. When we fill in our values here, you'll notice that they're in the same ratio as they were for our 30-degree, where let's see here. Yes, so they're in the same kind of ratio as our 30-degree triangle up here, where you'll notice up here for our 30-degree triangle, you know, a triangle has 180 degrees, all of its angles add up to 180 degrees. So you have your 30-degree angle here, your 90-degree angle here, and this would theoretically be your 60-degree angle up in this corner to make it 180 degrees in the full triangle. So bringing that down here with these same measures, this is our 60-degree angle here, this is our 90, so this would theoretically be our 30-degree angle to bring our full triangle to 180 degrees. If we look up here, they had the value being opposite, that the value opposite of 30 degrees up here was 1. If you take that down here, it's the same thing. The value across from our 30-degree down here is going to be 1, but in this case it's going to be -1 because we're moving to this side of the unit circle. Before we were operating on the positive x value side, but now we're on the negative x value side. In this quadrant, we're also in the negative y value side of our axis here. So if you look up here, opposite of our 60-degree measure up here, we have a square root 3. So opposite of our 60-degree measure down here, we're going to have a square root 3, but that's also going to be negative because we're in the negative values of our axis. And then for our hypotenuse, that's going to be the measure of the line across from our 90-degree angle up here. So up here that was 2 for this problem, and that's also going to be 2 down here. So we have those same kind of ratios as we did with the 30-degree triangle here. They do get switched up when we move to a 45-degree triangle, but they come back when we're working with a 60-degree triangle. So looking here, we can label our sides as we have done with our other problems. So we have the same hypotenuse here, hypotenuse here labeled in red, and we have the same opposite side labeled here in blue. And again, even though it's kind of inverted, it's the same locations with respect to where our theta is, because our theta value is here at 60 degrees. The side opposite of our theta value is going to be our opposite side in blue, and the hypotenuse is always across from our right angle. So we look at sine is our opposite over our hypotenuse, our blue over our red. So our sine of 240 is going to be our opposite, which is our negative square root 3, over our hypotenuse, which is 2. And because we have our square root value in the numerator, that's fine. We can just circle that and leave that right there as our final answer. Yeah, so I'm sorry, that got kind of confusing on the last one here. But yeah, so that's how you do your sine function.